All right, let's take a look at solving this problem. We want to find the domain of h of x, which is 12 over 6 over x minus 1. The answer entered in here is incorrect. So let's take a look at how to obtain the correct solution. All right, well, let's actually write the function so we can see it a little better. So h of x is 12 over 6 over x minus 1. And we're going to start by thinking of that as a composition of function. So we're going to take a function g, and into g we're going to put the function f of x. So we have to determine what does g of x equal and what does f of x equal. So when I've got a function, there's more than one way to set up the composition. For this problem, though, is the most reasonable way to set the composition up. So first of all, what I'm going to do is g is going to be the function that has 12 in its numerator and simply x minus 1 in its denominator. Now notice what I did. Instead of writing this expression 6 over x, I simplified that and just wrote that as an x in the function g. Well, that basically means that this x that in the original function was 6 over x needs to be replaced with f of x, or called f of x. So in other words, if I take this function g and instead of putting x into g, I put f of x into g, then I will now have my original function. And let me just do something real quick here, just to kind of illustrate this point. So notice how you start with g of x. And that's 12 over x minus 1. But instead of putting x into g, so I'm going to erase x, and instead of putting x into g, I'm going to put f of x into g. So notice all x's have been replaced with f of x. But what is f of x? Well, as we see on the line above, f of x is 6 over x. So that's just to kind of help explain why I define f as I did and why I define g as I did. So notice g of f of x is actually the h of x that I started with. So when we go to find the domain of this function, here are the things we have to be concerned about. Here's what's going to happen with this function. I'm going to take an x value, and that x value is going to be first the input for f of x. So I'm going to take x and I'm going to put it into f of x. So any x that I use, so this basically implies that x must be in the domain of f of x. If I'm going to put x into f, it's got to be in the domain of f of x. All right, then when I get whatever f of x is, that's then going to go into g. So that's going to be my input into the function g. So first x is going to go into f and give me f of x. And then whatever f of x is, that's going to go into g so that I get g of f of x. Now what this means is that f of x must be in the domain of g. Whatever f of x is, it has to be a value that's in the domain of g of x. So how do we find these two functions' domains? So those are the two pieces of information that I have to keep in mind. X is going to go into f, and whatever f of x is, that's going to go into g. So that means x must be in the domain of f of x, and f of x must be in the domain of g of x. So that's really what that's telling me. X has to make f make sense. F of x has to make g make sense. So let's look at these two functions. So what is, let's start with the x's that make f make sense. So f of x is 6 over x. So for this to make sense, the denominator can't be 0. Well, what is our denominator? It's x. So for this to make sense, x can't be 0. Now let's look at g of x, which is 12 over x minus 1. For this to make sense, the denominator, which in this case is a little more complicated than just an x, the denominator is x minus 1. That can't be 0. Well, what does that mean? That means x can't be 1. So f of x will only make sense if my x is some number that's not 0. G of x will only make sense if my x is some number that's not 1. Now let's look back at what we said on the previous page. We said that x has to be in the domain of f of x, and then my f of x must be in the domain of g of x. So x can't be 0 for f, and x can't be 1 if g is going to be defined. So we just said on the previous page that f of x must be in the domain of g of x. So if the domain of g of x is all numbers except 1, then f of x, in order for it to be in g's domain, f of x can't be 1. Well, what was f of x? it was 6 over x. So 6 over x can't be 1. So in order to simplify that, let's multiply the left and the right side of this inequality by x. And this will allow us to isolate x. So x is going to get multiplied by 6 over x on the left, and x is going to get multiplied by 1 on the right. So this becomes just a 6. The x's divide out to give 1. So 6 over 1 would just be 6. And x times 1 is just x. So 6 can't be x because if it is, f of x isn't in the domain of g. If x is 6, since f of x is 6 over x, if x is 6, 6 over 6 is 1. And remember, to be in the domain of g, you can't be 1. So if I need f of x to be in the domain of g, then x can't be 6. If I need x to be in the domain of f, then x can't be 0. So those are the two restrictions that I have to place on x. It can't be 0 because if it is, it's not in the domain of f. X cannot be 6 because if it is, then f of x is not in the domain of g. So those are the two values. All other numbers don't cause a problem for h of x. So the domain of h of x which is 12 over 6 over x minus 1 is, let's write that in interval notation as the problem asks us to do, all numbers left of 0. So I would write that as the interval from negative infinity to 0, and I'm not including the 0. So I show that with a parenthesis. Unite it with all the numbers between 0 and 6. Unite it with all the numbers to the right of 6. So notice how the 0 and the 6 are excluded. So this then is my final answer. So I have to make sure that I not only leave out the 0 that makes 6 over x undefined, but I have to make sure that I leave out the 6 because that gives me an f of x. So f of 6 is 1, and you can't put 1 into g. So that is the kind of reasoning and thinking that I have to do for this problem. Hope this helps.